Hello, advanced algebra students, and welcome back to another video lesson as we continue to work with radicals and radical expressions, where we learn more so how to evaluate, rewrite, and simplify them. We're expanding from last week, but now we also apply some of the properties to these nth root functions. Just a very quick heads up for this week so that you know where we're going, where we're at. We started radicals on Friday of last week. Today we're expanding a little bit. Tuesday, lesson 8.8, and then we're going to review all of that for another shorter mini test coming up on Thursday. Okay, so this is all, again, leading up to a mini test, a summative exam. Now, this is what we learned last week. How do we rewrite the square root of the cubic root of the fourth root of 10 only using one radical sign, right? So I want something times the square root of 10. How do we know what number? Well, we take these numbers that are on the shelves here, and remember, if there's nothing written, that represents a 2, and we multiply them. 2 times 3 is 6, and 6 times 4 is 24. So that problem up on top is really asking the same thing as finding the 24th root of 10. The 24th root of 10. And really, some of the questions you're going to have on this mini test are just like that. We don't need to know what the 24th root of 10 is. It's more so, can you simplify the 4 times the 3 times the 2 that's there to get the 24th root of 10. All right, here's a few more. Simplify the following. Try this first one, the 5th root of c to the 20th. Remember, this is also the same as saying c to the 20th to the 1/5 power. The 5th root is the same as saying the 1/5 power, which means the power to a power, the product rule, is to multiply 20 times 1/5, which is c to the 4th. C to the 4th. Try the second one. Square root of 144x to the 6th. Remember, that is like saying 144 x to the 6th to the 1/2 power. 144 to the 1/2 power, right? The square root of 144 is 12. And if I take x to the 6th to the 1/2, I'm multiplying 6 by 1/2 to get x to the 3rd. 12 x to the 3rd. And when we're simplifying, we're only looking for positive values. Now, the cubic root. Right, the cubic root of those. So why don't you pause and try this one. Okay, well, the cubic root of 125, that's 5. X to the 12th, then to the 1/3 power. Y to the 21st, then to the 1/3 power, right? We can change that cubic root to 1/3 so that I can use the product property of powers. So 12 times 1/3 gives me x to the 4th. Y to the 21st to the 1/3 gives me y to the 7th. All right, and so that's really what we were learning last week at the end of the week on Friday, trying to apply that radical rule and exponents, changing from cubic roots to the 1/3 power. Now, what we have to be able to understand is how and when we get some of these solutions and answers. So I want you just to take a minute and pause the video here to simplify these, either using a calculator or decimals, right? And it's just for demonstration purposes on this slide only. Remember, the mini tests in this chapter are going to be non-calculator. So take a moment and try. All right, if you punch this one in, the cubic root of 27, you should have gotten 3. 3 times 3 times 3. The 4th root of 16, when you punch that one in, you do get 2. Now, when you punch this one in on a calculator, negative 32 to the 1/5, you actually do get negative 2. Okay, but the textbook says that this one has no solutions or that it's undefined. And we're going to go with that answer because that's what the textbook says, but we'll talk about that in a moment. The fourth one, the sixth root of negative 64, well, that's also undefined. Okay, we're only working with real numbers in this chapter, right? And so I can't find the even root of a negative value because negative times negative times negative times negative times negative times negative is going to turn into a positive. 81 to the 1/4, well, that's 3, right? The fourth root, so 84 to the 1/4. The cubic root of negative 125. With this one we can find, and we'll say that this one is negative 5, right? So as long as it's written with the radical sign, we can do it, but when we're using rational exponents, we're not going to. The fourth root of negative 625 is undefined. The third root of 64 is 4. Okay, and so we're going to use these to just kind of write some rules, if you will, right? To just remember a few things. And basically, we're looking to see underneath the radical sign, you know, if it's positive. Look at all these positive ones. A, B, E, H, right? A, B, E, H. They all have answers. They all have real roots. Sometimes it's 2 and sometimes it's just 1, but they all have real roots. It's when we get to these negative values that we all of a sudden have potentially undefined or we do get 1 root, okay? And that's what we're going to summarize on this page, okay? All right, for the odd, and I'm going to break them up this way, okay? If we are taking an odd root or an odd radical, if I have an odd root of a positive number, we will get a positive solution. All right, if I have a positive number and I do it as a rational exponent, we also will get a positive. If I have an odd root of a negative radical, this will be a negative value. And now this one, right, these two are related, but if we do it as a rational exponent of a negative number, we don't have to worry about this one. You're not going to be assessed because the book says one thing, your calculator says something else. All right, so this will not be on the test. Okay, but that's when we are dealing with odd powers, odd roots. Odd of a positive is a positive. Same thing if we rewrite it using rational exponents. If I have an odd root of a negative, it will be a negative value. Down here, if I have an even root of a positive number, that will be positive, right? Think of square roots, the square root of 64. If I write it as 64 to the 1/2, that would also be positive. If I take the square root of negative 81, that's not real, right? We don't have real answers on these ones. And so in this chapter, we're only focused on the real. So that's not real, which also means if I write it with a rational exponent, it's also not real, okay? So anytime we take an even root or rational exponent with a negative number, they are not real. Now let's try and see what that means with just a few examples, okay? If we were asked to simplify the cubic root of negative 27, that cubic root, okay, well, first of all, we can definitely take a cubic root of a negative number because it's written as a radical. And what number times itself 3 times is 27? Well, that would be 3. But the only way to get a negative as a final solution is to have negative 3. Negative 3 times negative 3 times negative 3. You get the first two become positive, and then the third one makes it negative. Okay. The fifth root of 32. Again, we can take the root of any positive value. If we've got 5, that would be 2. The square root of 100, oh, that's 10. The square root of a to the 4th is a squared. The square root of b to the 8th is b to the 4th. Okay, and we're focusing on the value out front. Cubic root of 64 is 4. The cubic root of x to the 18th is x to the 6th. Right? So if I raised it to the 1/3 power, Okay, so again, we can't do it. We got to be a little bit more careful when we have a negative underneath, and whether or not we're dealing with positives and negatives, right? So, like the example would be, I don't know, the cubic root of negative 64. We can do that. That's pretty, standard. But if I were to change it to squared, we wouldn't be able to do squared, right? What we learned was that was 8i, imaginary. And in this chapter, we're only working with the real. Okay, but here's what we're really going to be focusing on when it comes time to the test, right? I'm not even going to really worry so much about the final answers on most of these. We're really trying to determine, is it going to give you something that's positive, something that's negative as an answer, or undefined, right? What type of answer is it going to give you? And so if you look at the first one, negative 3 to the fifth, right, to an odd power, negative 3 to the fifth. Well, if you quickly just write it out, negative times negative times negative times negative times negative, these two become positive, and those two become positive, but we're left with like one negative left over, meaning it would have a negative answer, right? That's why the odd will always give you a negative here. Whereas if I take 3 to the negative fifth power, what do we think? Is that positive, negative, or undefined? It's actually going to be positive. And let me try and show you why. What's the rule with negative exponents? We move it to the bottom, 1 over 3 to the fifth, right? 3 times 3 times 3 times 3 times 3. It doesn't even matter I think it's like 743 or something maybe. I don't even know. But the idea here is the negative exponent turns it into a fraction. Okay, it doesn't make it negative, it just turns it into a fraction. Negative 2 to the 14th. So negative 2 times itself 14 times. Now, because it's even, the answer here is going to be positive. Because all of those negative 2's end up canceling each other out. The negative parts do. We don't have the one left over like we would with an odd. The cubic root of negative 5. The cubic root of negative 5. This is going to be negative. Again, 3 numbers multiplied by itself, 1, 2, 3, to get a negative means we'd have to have negatives. The fourth root of a negative number, that one is not real. So we say that it is undefined, right? We can't figure out that in this section. Undefined. The sixth root of a negative number squared. Oof. Well, if we follow order of operations, we've got to take this number and square it. So anytime we take a number and square it, that number times itself, it's going to become a positive value in here. And then I'm taking the sixth root of a positive number, which makes this positive as well as a final answer. Okay, and so that's what you're going to be working with when we come time to test on Thursday in terms of, can you tell me if it's positive, negative, or undefined? The other avenue for this is to go backwards in a sense and write an expression that has a radical that would be undefined over the real numbers. So what is a radical that would be undefined? Think of our imaginaries. So any example, the square root of negative 81, the fourth root of negative 100, the 10th root of negative 1. As long as you have an even and a negative, it's going to be undefined. Can you write an expression, a fractional exponent that would be undefined over the real numbers? Couple of options. We could convert each one of these. Negative 100 to the 1/4. I could convert those into rational exponents, right? Or we said the other one that we really, weren't going to deal a whole lot with was if I had a negative and an odd. A negative and an odd. Okay? That negative and the odd. Now the last one wants us to take a radical, some radical, could be the third, the fourth, the squared, whatever, and we want the answer to end up being 2 x to the 5th y to the 3rd. So I want to take maybe the square root, maybe the third root of something to get this answer. Okay, well, what's the opposite? Like, how do I get that answer and put it under? We can basically take something out here, and let's just say we're going to square it. 2 squared. Well, that would be 4. X to the 5th to the 2nd is x to the 10th. Y cubed to the 2nd would be y to the 6th. And if I just left this as the squared, that means I would be raising it to the 1/2 power, and we would get that. Right? If I wanted to do it to the 3rd, right? Maybe we wanted to do it to the 3rd power. 2 times 2 times 2, 2 to the 3rd, that's 8. X to the 5th to the 3rd is x to the 15th. Y to the 3rd is y to the 9th, because I'm multiplying, right? This all goes back to some of the original rules. But now we got to be careful, because it's not just a square root. What number goes here? We raised it to the 3rd, so we took the 3rd root of this to go backwards. Right? If you have any questions, I can't encourage you enough to make sure that you reach out. Otherwise, until next time, everyone, stay safe.